In this third section on fire, smoke, and overheat protection, I'm going to look at the extinguishing systems that we find in transport category aircraft. So they're broadly broken down into two major categories. So we have on the aircraft, we're going to have various portable extinguishers shown here. Here's two different types. And then there are going to be permanently installed systems, looking more like what's over here on the right, that provide protection for various areas, things like engines, auxiliary power unit, APU, and cargo holds. Now, just a quick reminder, for fuel or for a fire to occur, we have to have three elements. We have to have fuel, an oxygen source or oxygen, and then a heat source or an ignition source to get it started. And the general idea behind fire extinguishing is that we are eliminating one or more of these three elements in order to stop the what is essentially a chemical reaction process that is fire. So we have various extinguishing agents that are available. So inside, whether it's portable or fixed systems, there are various extinguishing agents that we might see out there. And so some of the most common ones, the first extinguishing agent here I have are known as halogenated hydrocarbons, or we refer to them as halon for short. And there's a few different types shown here. Are two of the types, halon 1211 and halon 1301, are two common ones. But halon extinguishing, the big thing, it's actually got kind of two processes. The first is oxygen displacing. So halon is designed to we use it inside of an enclosed space, and it only really works inside of an enclosed space. And if we have an enclosed space, when we fill it with halon, it's going to push out any other atmosphere, particularly oxygen-containing atmosphere, from that enclosed space. And so that removes the oxygen. The other thing it does to some extent is it's held under fairly high pressure inside of bottles or canisters. And so when it is allowed to escape and it expands quite a bit, part of that is it expands to fill that space and flush out oxygen. But the other part is when it expands, it's going to get cool. It's going to cool off. And so it has a cooling effect to remove some of the heat of fire once it's going. If there isn't an initial ignition source, it's the heat of the fire itself that's the ignition source for continued combustion taking place. And so if we can cool a fire enough, it'll put it out. So between displacing oxygen and cooling the temperature of the fuel, it puts that out. The advantages of halon is it leaves absolutely no residue. Halogenated hydrocarbons, it's a gas. It has no residue. It's non-conducting, so it's not electrically conductive. So it's often used in areas where we wouldn't want to put water onto a high voltage area, for instance. And so not only do we see it in airplanes, but you see this in things like like server rooms, data centers, things like that, where we don't want to dump water everywhere. It is low toxicity. Now, don't confuse toxicity with oxygen displacing. So if you breathe in halon, it's not great because it prevents you from being able to breathe in oxygen. However, if you do breathe in halon, at low amounts, it's not going to poison somebody. The idea, though, is that if you are in an area that's being filled with halon, because it's oxygen displacing, it can cause suffocation. So we have to be careful working in spaces that have these, that we don't, potentially harm somebody because of the suffocation risk. The one downside is that halon can react with certain burning metals, and in today's day and age, the big issue there is lithium-ion batteries. And so those of you that have flown recently may have heard or seen or be aware that airlines and the FAA, they do not pack lithium-ion containing items like things like laptop batteries in checked luggage. And the reason for that is the checked luggage is going to go into a cargo hold, and most of those cargo holds have halon extinguishing systems if a fire were to break out. And so we don't want that halon reacting with lithium-ion batteries if those are what caused the fire. Another type of inert gas, but just kind of inert gas category, is things like nitrogen and carbon dioxide, CO2 being the most common. And so some aircraft did have CO2 extinguishers, although they're not as common today. And I'll talk about the reasons for that in a second. But CO2 again is oxygen displacing, so similar to halon in that it separates the oxygen from the fire. It doesn't leave a residue behind. When it expands, it gets cold, so it has a cooling effect. But the reason that CO2, nitrogen aren't used as much anymore is because they're not as temperature stable as halon. So halon inside of an enclosed chamber, as it gets warmer, if you have a gas in an enclosed space, when it gets warmer, the pressure increases. When it gets cooler, the pressure decreases. Halon has a lot less of that going on compared to CO2. So CO2 can have a fairly significant amount of pressure increase in an enclosed space if the temperature of that container gets high. So there is a risk there of it causing an overpressurization if it gets too hot. Some of the other extinguishing agents, another one that's a great agent is water. Water is used because it's non-toxic. It is cooling. So the big reason water works is it cools off the chemical reaction, and it pulls when the water hits fire. It instantly boils, turns to steam, and that pulls a lot of energy away. But water leaves behind water, and so we don't want to use water necessarily in areas where there's electrical or other things like that. It has a certain amount of corrosion risk, and so water really is only used for portable extinguishers in the cabin for things like trash fires. Like if you have a trash can that catches fire, because the most common reason a trash can catches fire is in like a lavatory is that there's paper towels in there and then somebody throws a cigarette butt or something like that. That's not as common today, but occasionally we still do get somebody who just can't go without their fix and they light up in the lavatory and then set off the smoke detector and panic and throw the butt of the cigarette into the trash. And so if a flight crew notices it also, or like a galley too, someone will flip one in a galley trash container. And so if a crew notices a paper fire, they will have a portable water extinguisher. The last one shown here is dry powder. And this is very similar to what, if you've ever used a fire extinguisher in your home, most of those contain dry powder. Dry powder leaves a residue. If you ever operated a dry powder residential home extinguisher, when you're done, there's white powder everywhere. And it's the primary chemical used for that is monoammonium phosphate. And this works primarily by separating the fuel from the oxygen. So that white powder layer coats whatever is burning, and it creates a physical barrier between the fuel source and the oxygen that's in the atmosphere. This isn't very commonly used at all in transport aircraft. The big reason for that is monoammonium phosphate is very corrosive, and so when it gets on particularly aluminum structures and into cracks and crevices, you're not cleaning all of it out. It works its way everywhere, and then that powder sits on whatever it's come in contact with, and it can cause corrosion. So we don't see that too often. So looking at portable extinguishers in a little bit more detail, areas where we may have portable extinguishers, the flight deck crew typically has a portable extinguisher up on the flight deck. The cabin crew might have one or more available back in the cabin. And the agents used in portable, there are halon portable that are designed to be discharged into enclosed spaces like trash cans or into a enclosed bin or cargo container on a cargo type aircraft. CO2, sometimes in the cabin we will have dry powder extinguishers, again for fires in the cabin that are more similar to what you would experience at home. And then the one shown here on the left, this is a water extinguisher. And so as I mentioned, the water extinguishers are good for things like paper fires. So these are broken down into four classes or kind of categories, and it has to deal with what they do. And so the first is category A, class A, which is your ordinary combustibles, wood, paper, etc. And on an airplane, these are almost always your water. B is things like flammable liquids, greases, and oils, and the most common there is dry powder. C are electrical fires, also dry powder. And then D, flammable metals are a dry powder. They're a different part of dry powder. We don't really carry these on aircraft too much. So typically, the one on an aircraft, we have these Class A water extinguishers, and then we'll often have an ABC, one that's designed for can be used on Class A or B or C. That does use a dry powder and again used if absolutely necessary.